Happy morning to everyone. Today I'm going to discuss principle of laser. This topic belongs to the paper called as an engineering physics. That is common to all circuit branches in KSR College of Engineering. And subject code is 24 PH I07. Credit for this paper is 04. And we have five different units in engineering physics. One is laser and their technology. That is what I'm going to elaborating today. In this topic, first of all, we have to understand what is laser. Laser is nothing but it is an acronym, which means light amplification by stimulated emission of radiation. And a laser is a device, electronic device that is used to generate an amplified, coherent, monochromatic, and highly directional beams of light in visible and invisible regions of electromagnetic spectrum. So it's a very power. Simply, we are saying that laser is a very powerful light source other than conventional light sources. And the basic principle of laser is stimulated emission. Stimulated emission is nothing but before we deals with stimulated emission. I want to tell you the unique properties of laser. What are the unique properties of laser? Directionality, coherence, monochromaticity, and intensity. Directionality is nothing but the light energy is directional. Which means they can travel a long distance without any loss of energy. That is called directionality. Whenever the directionality improves, the second property of laser is intensity. That is also directly proportional. So that light is concentrated means light. It's more intense. And after that, the third property is monochromaticity. What is monochromaticity? Which is very simple. The laser light is in one of the highly monochromatic light because it exhibits a single wavelength whenever it is traveling through any type of medium. That is the greatest advantage of laser, which leads to many applications, irrespective of field, like a medicinal field or industries or engineering, any area. Why we are using lasers? The main property is monochromaticity. And the fourth property of laser is coherence. Coherence is nothing but the laser light is coherent means the light waves within the beam are in phase. That is, the conventional light sources are out of phase, but they are in phase. That means the identical uh, the identical particles, they have identical spin, identical direction, identical velocity. That is, these things are collectively called as coherence. So these are the unique properties of laser. And history of laser. History of laser is very interesting one, because in the year 1917, the idea concept the concept is taken out by Albert Einstein in the name of stimulated emission. That is the first theoretical foundation for laser light. In 1954, Charles Townsend and Scalo proposed a laser using microwave radiation. In the year 1960, T.H. Maiman, popularly known as Theodore Maiman, builds the first working laser using a ruby crystal called as a ruby laser. Presently, lasers are many, and we are using in all kind of applications in that, from the education institutions to research labs, industries to engineering fields, medicinal field to research R&D departments. In many areas, lasers were used. Principle of laser. The basic principle behind the laser device is stimulated emission. Stimulated emission is nothing but an atom excited from lower energy level to higher energy level means they have a two possibilities. One is spontaneously emitted, another one is stimulated emitted. What is spontaneous emission? The excited atom comes to the ground with the emission of energy without any external triggering means that is spontaneous emission. But what is stimulated emission? It's just contrary to spontaneous emission. That means the excited atom come to the ground state with the emission of light energy with an external trigger. If you are triggering the external excited atom comes to the ground state, then it emit two ranges of light energy. That is called stimulated. That type of emission is stimulated emission. For example, the stimulated emission is graphically explained here. Here, the third case is stimulated emission. The first case is absorption. The atom in the ground level absorbing some energy and goes to the higher energy level. Spontaneous emission means the excited atom in the higher energy level comes to the ground state with the emission of photon. That is spontaneous emission, which is without any external triggering. But in the case of stimulated emission, we are sending a light energy that is interacted with the excited atom in the higher energy state. Then the higher energy state, the excited atom comes to the ground state with the emission of light energy. There are two light energies is exhibited. Yeah. Uh, I am telling you, laser is an light amplification by stimulated emission of radiation, which is an acronym. Yeah, you already know. Why we are using stimulated emission as a basic principle? The reason is spontaneous. The light emitted from the spontaneous emission is not coherent, not directional, not monochromatic, and not intense to be. That is why we are having another. We are choosing another emission is a basic principle of laser. In the case of stimulated emission, the light energy emitted from the stimulated emission is highly directional, highly monochromatic, and high coherent light and high intense light. That is the reason why we are choosing stimulated emission as a basic principle of laser. Right. And then types of lasers. Types of lasers, we have a major categories in lasers. One is a solid state laser. Second one is a liquid state laser. Third one is a gas laser. Fourth one is a semiconductor laser. Fifth one is a dye laser. So these are the different types of lasers. And how laser works, that is the main important thing. Light is amplified through the process called stimulated emission. I'm already telling you. Ordinary light is amplified through the process called stimulated emission. That is why we are found a name laser. The amplified light is reflected back and forth in a resonant cavity to create a beam of coherent light. The laser beam is emitted from the cavity, producing highly focused and intense stream of light. So, in this way, the laser is working. Components for lasers. This is another very important. If you want to build your own laser means you must have the following four requirements. One is an active medium. Active medium may be solid, liquid, gas, or a semiconductor or anything. Active center in which atom goes to the higher energy level from the lower energy level. That particular atom is nothing but an active center. For example, if you are taking ruby as an active medium means ruby atoms are active center. That's all. Next one is a pumping system. Pumping system is one of the most and important requirement for making a laser system. In pumping, we have a resonant cavity in the form of a glass tube, which is preferably made by quartz material, which has a two ends. One is a partial reflector, another one is 100% reflector. So here, in this, the active medium is kept in between the pumping source, so that the process is happen. That means stimulated emission is happen means the photons are emitted from the material and they are travel back and forth between the partial reflector and the 100% reflector, so that high intense beam is produced that will be released from the optical resonator. So these are the important requirements for constructing the laser system: active medium, active center, pumping system, and optical resonator. And Einstein's quantum theory of radiation, I already told you in the year of 1917 only, the basics and theoretical, Albert Einstein laying a foundation for theoretical evidence for stimulated emission. So that is the theory called Einstein's quantum theory of radiation. In our another video, we have to describe about Einstein's quantum theory of radiation. Right, that's all. And the real-time application of laser, that's a very important thing. Whenever you are trying to learn about something, some electronic devices means you have to know the real-time applications. In the communication area, fiber optical data transfer, we are using laser light. Medicine, eye surgery, most of the invasive surgery, non-invasive surgeries, we are using laser light. For example, endoscopy, fibroscopy, laparoscopy, etc. Entertainment, laser shows, CD and DVD plays can be written with the help of written or recording with the help of a laser light only. Industry, all the engineering applications like cutting, building, drilling, 3D printing, etc. In electronics, we know that every supermarket, every any other commercial buildings here, we easily know that the barcode scanners, that is the real-time application of laser. And measurement, range finders, laser vessels, laser levels. These are the things, how to decide the distance or location of the any undisputable objects. security, biometric scanners. It's a inevitable device in employable all the industries and any software companies or anything. Security is very important. So that biometric scanners using laser light and automatic laser headlights, research, microscopy, material analysis. If you want to analyze the material deeply, means you have to use laser light, X-ray diffraction. Likewise, the laser diffraction is also available there to analyze the materials. Um, things and consumer gadgets, laser pointers, proximity sensors. These are the things, the real-time applications of laser. So, from this video, you can learn about what is laser, what are their properties, what are its types, and what is the basic principle behind the laser device, and how to construct a laser device, and finally, the real-time applications of laser. Thank you all. In another video, we will meet and my friend, we will explaining laser deeper. Thank you. Thank you. Yeah, beautiful.